Lines, line is an infinite string of points. Okay, because a line is infinite, it has no length because it cannot be measured. We can't measure infinite things. A line segment is a finite piece of a line. It has two endpoints, and it can be measured. Okay. So anytime you actually draw a line on a piece of paper and you called it lines your whole lives, those were really line segments, because you can't draw a line because they go on forever and ever and ever.
Because they don't have points.
No, they have points. They're just infinite points. They don't have end points though. Okay. Metric units, we have millimeter, centimeter, meter, kilometer are the most common. You also have decimeter, decameter, and hectometer, but we don't really use those. Okay. So, you're all familiar with the ruler. The big lines are the centimeters, and the little lines in between them are the millimeters. There are 10 millimeters in 1 centimeter. So if you have a place that it doesn't line up perfectly on the centimeter, so each millimeter can equal a decimal point because of the 10 inside. So you can say, for example, here we're lining up pretty perfectly, so that would be 4 centimeters. But here we're lining up less perfectly, and that picture is not good, but I think it's on the 4 millimeter mark after the 4.
So each ruler comes with like 10 millimeters, right?
A ruler has 30 centimeters and 12 inches.
Well, wouldn't it be centimeters instead of 4.4?
Oh, yes, it would. Thank you. I got confused. Yes. So you could say 4.4 centimeters, or you could say 44 millimeters. Because each centimeter is 10 millimeters. Here we're at about 5 and 3, I'm going to say. So I could say either 5.3 centimeters, or I could say 53 millimeters. Wrong when they're measuring is they line up whatever they're measuring with the very edge of the ruler, like that. But if you look, my 0 centimeter is here, not here. So when you're measuring for accuracy, you want to line up to the 0. Do you see what I mean? Instead of the end of the ruler, you want to line up with the 0. So if I come across here, I'm at 15 and then 6 millimeters. If I was here, which, you know, is that brings me all the way down to 15 and 2. So that's 4 millimeter error in measuring. So you just want to be careful to line up at the 0 and not at the edge. Okay. So as it was 15.6. So we have a dollar bill in centimeters is 15.6. Now when you guys do things like this, measuring pencils, well, it will depend on your pencil, wouldn't it? You know, 3 different pencils, 3 different lengths. Which one do you want to measure, the long or the short or the medium? Where is my... So if we take that, again, I'm going to line up the tip of the eraser with the tip of, can't even see that, the tip of the eraser with the 0. And my pencil lid comes to 14.5. So oh, but I was supposed to do millimeters, so that's
Like
145 millimeters. Standard units are also known as English standard. So we have inches, feet. Oops, feet has 2 E's. Yards, which is YD, and feet is FT. Now with inches, we don't have the same E's as we had with metric. Metric is base 10, so each millimeter is the same thing as a decimal point, but with inches, each line in between is a fraction. So if we're here, the tallest line in the middle is 1/2. Okay.
So if it went, what would be the next one? 1/3?
Nope, these right here, halfway between the 1/2s, the red that I just marked, those are 1/4. This one then would be 3/4 because it's on the other side. And then the smallest one is an 1/8. These are 1/8. So we're back to blue with 1/8. This would be 1/8, 2/8, which is 1/4. So that would make this 3/8, 4/8, which is 1/2. So this one would be 5/8, 6/8, which is 3/4. So that would make this 7/8. So when you're talking about inches, you can't just easily say, oh, there's 5, so it's 0.5, or there's 6, so it's 0.6. It's not as convenient. So you have to learn the fractions. Some rulers have another smaller line in between the 8ths, and if that's the case, it would be 16ths. But that's the smallest they go. Okay, so when we look at these, we can't say, 2 point something. We have to say 2 and then you have your fraction. So this one would be just our 4 inches. Here we have 2 inches and it lines up with this line. So that's 1/4, 1/2, 3/4. So this would be 2 3/4 inches. This one would be 1 and, anybody? 1.5. We're lining up at the tall one. And then this one lines up with that. 7/8. Okay. Same thing with the dollar bill, and the same thing with the inch ruler. If we look at that, the end of it, the 0 still doesn't line up with the very end. So you have to line up with the 0. And this particular, so that's 1/2, 1/4, and 1/8. So this one has 16ths. Do you see that? Like if I look right here, that's 1.5. Halfway between the 1.5 and the 1 is the 4th. Halfway between that is the 8th, and then the smallest one is the 16th. So Measuring this dollar, I'm at 6, and in this case, 6 1/8. So 6 1/8 inches is the same thing as 15.6 centimeters. Okay. And we'll measure the same pencil. If I can find my mouse. Okay. So again, I'm lining up the tip of the eraser to the 0. And I come to, there's 5 1/2. So that would be, 1/2 is the same as 4/8. So that would be 5/8. But I think we're actually at this 16th right here. So this would be 10/16. So that would be 11/16. And if you have a hard time with the fractions, you can just count the little dots. So we're at 5 11/16. Segment addition. Basically, this is another postulate which tells me that if I take two segments and I stick them together, I can add up their lengths and it equals the length of the new one. Which just makes sense, right? If I take two things and I put them together, they're now worth both. So when this happens, you just add the two parts together and you get the whole. So EF is 2 3/4, FG is 5 1/2. We want to find EG, which is the whole thing. So I say 2 3/4 plus 5 1/2. And I have a problem.
What do you have to find common?
I have to find the common denominator, which is going to be 4. So I'm going to multiply both of these by 2, which is going to change this to 2 3/4 plus 5 2/4, which is going to give me 7 5/4, which is 8 1/4. Go from the 7 5/4 to the 8 1/4. This right here is an improper fraction. So this is 1, because 4/4 would be 1, right? And then we have 1/4 left over. So to figure that out, I would say you take 4 and you divide it into 5, and that gives you 1. That's your new whole number. And this is your new numerator. Your remainder becomes your numerator. And your quotient becomes your whole number.
So if your leftover, so your remainder, you just add it to that 7?
The remainder is right up here.
Okay.
The whole number gets combined with the 7 to make the 8. Does that help?
Okay.
A little bit. Here, like if I had, let's say I added some things together and I got 17 9/4. Okay. I would take that 4, divide it into 9, that gives me 2. 4 times 2 is 8, so I have 1 left over. So 9/4, this part, is equal to 2 1/4. So basically 17 9/4 is equal to 17 and 2 1/4. Does that make sense?
Yeah, okay.
And then the 17 and the 2 get combined to give you the 19 1/4. Better? Okay. Yeah.
Could you do an example, please?
Absolutely. Do you want me to start at the very beginning with the converting to the common denominator and go from there? Okay. Everybody got this one down? Okay. Let's do, say, 3 2/3 and 5 7/9. Okay. I can't add 3s and 9s together. They're not the same size piece. So that's why we have to get the common denominator so we have the same size pieces. A 3 will become a 9 if I multiply it by 3. But I can't just multiply the 3 by 3. I also have to multiply both the top and the bottom by the same number. So this becomes 3 6/9 plus 5 7/9. So then I add the 6 and the 7 to give me 13/9, and the 3 and the 5 to give me 8. But 13/9 is improper, so I have to convert it. So I'll take that 9 into 13. 9 goes into 13 once, with 4 left over. This becomes the whole number, and the remainder is the numerator. So 13/9 is the same thing as 1 4/9. So far okay? Okay. And then this 1 and this 8 get added together. So we add those two to get 9 4/9.
Could you cross out both 9s and just get 9 and do that?
No. Now, the other way you can do this, if you don't want to have this situation, is you can make these improper to begin with and go from there and just deal with all improper fractions. Would that be more comfortable? No? Okay. We're going to find JL, so I'm going to add the 8.4 centimeters and the 3.9 centimeters. So 4 and 9 is 13, 9 and 3 is 12, so this is 12.3 centimeters. Oh, sorry, I left off my inches. Just in the same that we can add two segments together and get the bigger segment, we can take a big segment and subtract a small piece to get the other piece. So this would be actually segment subtraction. So AC is 13.2, BC is 5.8. I want to find AB. So I'm going to do 13.2 minus 5.8. Borrow that. And 12 minus 8 is 4. And 12 minus 5 is 7. So this is 7.4 centimeters. Same with the fractions. PR is 13 3/4. PQ is 6 3/8. So I'm going to take that 13 3/4 and I'm going to subtract 6 3/8. But I need a common denominator. So I'm going to multiply both of these by 2, which is going to give me 13 6/8 minus 6 3/8. 6/8 minus 3/8 gives me 3/8. 13 minus 6 gives me 7. This section is that we're going to use algebra now with the segment addition. And so this is going to combine a couple skills. It's going to combine algebra with segment addition with being able to draw the geometric picture based off of the description. Okay, so we want to find the value of A. So this is our unknown. This is what we're looking for. Okay. And XY. Y is between X and Z. So I'm going to draw that first. Okay, so that's just Y is between X and Z. xy is 3a, so xy, that's 3a. xz is 5a minus 4, so that's the whole thing, xz. And yz is 14. If you take the time to draw the picture, these are easier because you can see what you need to do. These two pieces together make the big piece. Everybody see that? So what I'm going to do is I'm going to take those two pieces together and they make up the big piece, so they're equal. And then I just need to solve the equation to find a. So to solve the equation, I have a's on both sides, so I'm going to subtract one from the other. And you can subtract 5a from both sides or 3a from both sides, that doesn't matter. Then I'll add 4 to both sides. And then I'll divide by 2 to get that a is equal to 9. Okay, so I found a. But I also have this find and xz, so I need to, xy. I have to find that too, xy. Well, xy is equal to 3a. And a is equal to 9. So xy is equal to 27. So I found both answers. All right, so we have one more example like this. We want to find x and BC. Okay, so again, two parts. B is between A and C, so that's probably too high. So I'm going to draw that again. So I have A, and I have C, and B is just between them. AC is 4x minus 12, so this whole thing, 4x minus 12. AB is x. And BC is 2x plus 3. Are there any questions at all on the labeling, or is that part okay? Again, having the picture, it's easier to see that x plus 2x plus 3 is going to equal 4x minus 12. This plus this will equal that. Okay. X plus 2x is 3x. Would you like me to subtract 3x from both sides or 4x from both sides? 3x. Okay. We want our x's positive. Got it. Okay, and then we add 12 to both sides. And you get 15 is equal to x. So that's the first part done. We found x. Now we have to find BC. BC is 2x plus 3. X is 15. 2 times 15 is 30. So BC is 33. So found BC. Congruent means the same length. Okay, so congruent segments are segments that have the same length or same measure. The symbol for congruent is a squiggle over an equal sign. Okay. Pictorially, if I have congruent segments, they have the same number of hash marks. So A, B, and CD would be congruent, and E, F, and GH would be congruent. So if they have the same number of lines, they're congruent. And so I would say that AB is congruent to CD, and EF is congruent to GH. Line segments, I forgot to go over that. If I'm talking about a line segment, that's line segment AB. The length of the segment is AB with nothing over top of it. So if I have the line over it, I'm talking about the actual physical segment, and if I don't have the line over it, I'm talking about the length of the segment. And lengths aren't equal, or sorry, lengths aren't congruent, they're equal. So lengths equal segments congruent. So if you're talking about the actual physical segment, you say they're congruent. If you're talking about the lengths, you say they're equal. But it's really the same thing. It's just that I'm talking about, here I'm talking about the physical piece, and here I'm talking about how long it is.
So when it's equal, it's just how long it is?
Mm-hmm. And then when it's congruent, I'm saying that they're the same. Yeah.
Why is there two lines on EF and GH?
So the one line tells me these two are the same length. Two lines tells me these two are the same length. But one line and two lines tells me these two are not the same length. Does that help?